Hey everybody, this is Nick Simpson, and here I am going to go ahead and explain resilient file systems today, or ReFS for short. So let's go ahead and give it a go. All right, so what is ReFS? So ReFS is a file system that helps to detect any errors or corruption in the computer disk. I know it says file system, but more so the computer disk, and to prevent the spread of any corruption to the rest of the stored data on the disk. So essentially what it does is it creates a mechanism allowing for better protection of data throughout the disk and the data structures in the computer itself. Is a very useful measure that helps to create a more secure environment for storing data. Originally, it was introduced with Windows 8. They put it in the Windows 8 servers before they brought it up to speed because they didn't want to phase out some of the older file systems, for example, NTFS or FAT, I believe it was 32. They didn't want to phase those out yet. So they went ahead and added, well, not went ahead and added, but they went ahead and started to use ReFS in the Windows server and slowly integrated in with the later iterations of Windows. So as you see here, it uses a lot of the same drivers as NTFS, as that was one of the more popular drivers with Windows originally, including the caching, security, and APIs. So with that in place, they didn't have to totally scrap what was already working and stuff like that, since most of the computers, especially with Windows 7 and Vista, for example, were using NTFS. They didn't want to totally scrap it, so they decided to reuse like the caching information, security, and even some of the same API, and they just repurposed it for use in ReFS. The only major difference between the two is the fact that the information related to how the data itself is stored on the disk is changed due to the different security measures and whatnot. So on to the next slide. So what does ReFS protect from? So the checksum is, so what ReFS does essentially is it creates checksums for all the data. It adds up all the data and whatnot and creates a checksum. So then it'll use that checksum to compare to the mirror image of the data on the disk. And from there, it'll go ahead and compare the checksum, so that way, say something happens with the data on the disk or something of that nature, it'll be able to check that checksum and see that the values are different, and from there can use the mirrored image of the original data to restore it. So the checksum is a really useful measure to protect against some of the three major concerns when it comes to writing to the disk. These include bit rot, lost writes, and misdirected writes. So bit rot is essentially when the data that has been stored correctly gets corrupted due to the magnetic mechanism that the disk uses to store the data. A lost write is when data was supposed to be written to the disk, but for one reason or another, it doesn't make it to the disk, and that can be a result of a number of different things, from the file system itself being messed up or anything of that nature. A misdirected write is where there's an issue somewhere in the system, somewhere like the firmware sometimes, or even the drivers that the file systems use. And that means, well, that would lead to the data that was supposed to be written to the disk actually being written on the disk, but in the incorrect location from where it was supposed to be written. And one other mechanism, I mean, one other thing that it helps prevent is cascading failures. And this is when there's an uncorrectable problem that happens and the data isn't mirrored. So none of the mirrors are, well, either the data isn't mirrored or none of the mirrors are valid. So the mirror image of the data is also invalid, so it can't be corrected. So with ReFS, instead of taking the entire volume offline, which wouldn't allow you to access any of the data on that same volume, ReFS makes a record of all of the data. That way, it'll remove the corrupted data while still allowing you to access that same volume in case you have any like information on that same volume that you want to save or anything like that. So back to what ReFS does. So ReFS, it calculates a checksum and it stores for all of the data and metadata that's stored. So when the data is read, the checksums can be compared just to verify what was stored and that the computer is reading the data from the correct place. Because say it's reading it from a different drive, those checksums will obviously be different, and it would be able to move on to another location to verify that the correct data is in that location. It can also help determine which is wrong between the mirrored pair and the original pair, thanks to the large changes in the checksum, even when there's a small change to the data that help to calculate that checksum, whether it be lost, corrupted, written in the wrong spot, or just reading the incorrect location, it's very quickly apparent that there's an issue, and a lot of times ReFS can determine what the issue is just based off of the differences in the checksum. And all of those are tested independently, so the original image is tested by itself, and then the mirror image is also tested by itself to make sure. ReFS also helps to protect against bit rot by doing scrubbing. And what scrubbing is essentially that's when all the data on the disk is read over and the checksums are compared to the original stored ones. And if there's any bad data on the disk, say from bit rot or anything like that, it can alter the checksums if that needs to be done, or it can just read the mirror copy to verify that that has the correct checksums, and then use that to go ahead and repair and or replace the bad data, depending on how severe the damage is. So some of the downsides to ReFS include that it does not, it does not allow for hard links, which was a staple in Windows Vista and Windows 7, as I was previously saying. So it doesn't allow for a single file to have multiple names at multiple paths. So that's no longer allowed. Another feature that they went ahead and removed is data transactional updates, which essentially just allow transactions very similar to like a database to be made to the file system itself, and they went ahead and altered that as well. And some of the other notable features that were swapped out include data streams, which is very useful for sending files from Mac to Windows, storage quotas, and per file compression and encryption. So do you can't encrypt or compress files per file. So these were all major staples to Windows, and it took a little while to get adjusted to the changes. And that is the conclusion of my presentation here. I just want to give you guys a short little presentation on ReFS, and I hope you enjoyed it and have a great day.